Okay, we're going to look at frustum of a pyramid. So this is the frustum, that's a truncated pyramid. So what I will do, I will derive a special formula for the volume. So they say the diagram is a truncated regular pyramid. Remember, it must be a regular pyramid. If A subscript 1 and 2 are the areas of the top and bottom, as you can see, this is the area for the top, this is the bottom. Derive an expression for the volume of the pyramid if the perpendicular distance, that is distance from the two tops, is h. First of all, what I will do, I need to complete the pyramid to get the original pyramid. From there, we can use it to derive that of the frustum. So if I complete it, so this is the original pyramid. So we have two pyramids here, the one with base A subscript 2 and the one with base A subscript. So let's call the height of the big one, let's call it big letter H. So from here, so I'm saying from here down here is H. Why that of the small one will now be H minus H, that's big letter H minus that, because here is small h. We've known that the volume of a frustum, we know that the volume of a pyramid is 1/3 base area times the height, perpendicular height. So from here now, the volume of this frustum is now volume of the big pyramid minus volume of the small pyramid. I will know that the volume of a pyramid is 1/3 base area. So for the big one, the base area is A2 and the height is big letter H. While for the small one is 1/3 base area, which is A1, and height H minus H. So let's just open up this so you can see I have H here and I have H here, so I can factor this as 1/3. You get, I have H, so 1/3 A2 minus A1 H for this, and plus 1/3 A1 H. Do you get the logic? If you open this, I'll get minus 1/3 A1 H, which I factored with this one to have this, and finally this is now this times this is plus. So this is our equation 1. And remember, we are not given big letter H, so we need to write big letter H in terms of other parameters, that's the A1, A2, and so from here now we'll move to similar, but from similar polygon, which is that the ratio of the areas from similar polygon would that have the ratio of area is the same as the ratio of the squares of the corresponding side. So in this case, the height is the corresponding. So for A1, the height is H minus H. That's a theorem in similar triangle. So the ratio of area is the same as the ratio of the square of the corresponding sides. In this case, we are using height as the corresponding side. So which could be written as, we can factor this as H minus H over H all squared, which can still move to 1 minus as one whole number minus H minus H all squared. So let's continue. So we now have, let's just we'll move this square to the other side to be square root of that. So I have that 1 minus, so I have that 1 minus H over H is now square root of A1 over A2, which is the same as A1 square root of A1 over square root of A2. So the next thing is to remember our main aim is to make the big letter H the subject of formula. So if you move this to the other side, you have H over, that's positive, is equal to 1 minus square root a1 over square root 8. Do you get the logic? We'll move this to be positive, so this comes to be subtracted from 1, and we can see that this is the LCM of that is square root a2. So this in this one, so I have square root a2 minus square root a1. So the next thing we'll have to reciprocate. We now have h over h is now square root a2 over square root a2 minus square root a1. So we can rationalize this. That's multiplying up and down by the conjugate of this. So if I multiply up and down by square root of a2 plus square root of a1, that's to remove the sword in the denominator. So we now have that we're left with a2 minus a1, that's root a2 squared minus root a1 squared, which is a2 minus a1. Therefore, making h the subject of formula, h is now square root a2 times square root a2 plus square root a1 over a2 minus a1 times h. So let's call it equation 2. So what I will do now, I'll go to equation 1 and substitute this, because this is the unknown here. We know h, we know small letter h, and a1 and a2. So if we substitute, so now we see that the volume of the frustum is now equal to 1 over 3 a2 minus a1 times h, and h is square root a2 times square root a2 plus a1 times h over a2 minus a1 plus 1 over 3 a1h. I've substituted it. I just substituted this with all the expressions, so the others are the same. So we'll still solve. So we can see that this. So we now have the volume of the frustum is now, if you cancel this and this, you notice that, okay, let's expand this. We have 1 over 3. This times this is a2 plus y this time, that is square root a1 square root a2, and finally times h plus 1 over 3 a1 h. And this, you can see that they have the common term here is 1 over 3h. So if we factor 1 over 3 here, we have h over 3 now, and we are left with a2 plus, we can write this as a1 times a2 plus a1. Do you guys, I factored h over 3, so we're left with this in this first one, which is this, and this in the second one. So this is a formula. Okay, maybe let's just write it a1 plus a2 plus square root a1 a2. So that's the volume of a frustum of a pyramid. Yes. So it's very simple to remember. So look at this question. Let's use it and solve this question. We are asked find the volume of the figure as shown. So it's a, you can see it's a regular of the figure. So it's a regular pyramid. So applying the formula now, volume of the frustum is now 1, that's h over 3. Our h here is 9. 3 And what's the area? A1 is 25, A2 is 81 plus square root of 25 times square root of 81. So this is 3 times, this is 106 plus 5 times 9 is 45. So this is 3 times, this is 151. So the answer is 353. So the answer is option C. So the formula is very easy to use. So once you know the area of the top, the bottom, and the distance between the two tops, or that's the volume. You don't need to waste your time. Thank you.